Good afternoon, everybody, and welcome to the What You Need to Know About Flash webcast. We will begin at the top of the hour, and we'll have be muted until that time. Thank you. Good afternoon, everyone, except for those on the West Coast, and welcome to Datalink Webcast, What You Need to Know About Flash. My name is Kent Christensen. I'm a practice director here at Datalink, and I want to introduce Jason Anderson, principal architect at Datalink, to lead the webcast. Jason? Thank you, Kent. Today, what we're going to talk about is flash storage and how it's changing the landscape of flash in the data center environment. So today's agenda, we'll talk about how flash is changing storage landscape, a deeper look at flash technology, use cases where flash is appropriate,
the different types of flash solutions that are available, and highlighting some of the leading all-flash technologies that Datalink has worked with. So first, a little bit about Datalink. Datalink is a approximately $600 million company. We are public, traded on NASDAQ. We are a data center-focused solutions and service provider, primarily focused on Fortune 500, Fortune 1000 customers. Top partnerships amongst the leading IT equipment providers. So approximately $180 million in revenue from services and contracts. Offices throughout the United States, and have been in business for close to 30 years with data center expertise. So our makeup of the organization is very focused on technical personnel. So of the 500 plus employees, approximately 85 of them are in sales, with the rest primarily focused in engineering. So the bottom line is that we're a differentiated solutions provider, focusing primarily on technical capabilities and delivering integrated solutions in the data center. So with that in mind, so why is it we're talking about flash? So flash is fast, it's sort of kind of to state the obvious. But what we're starting to see is the movement away from spinning disk and towards flash, in a similar movement that we went from tape to disk several decades ago. That the ability to access information more quickly and in a fashion that gets the right information into your application when it's needed is causing us to transition away from the long-standing spinning disk drive and into flash media. So what this is really boiling down to is, what can it do for my business, whether it's analyzing trades multiple times faster, a doctor reducing the amount of time it takes to take care of a patient, perhaps if you're running a call center, being able to reduce the cycle time by 20% and improve the productivity of your employees. So what's driving this transition in 2014 as opposed to in years past is that applications beginning to value the cost of an IOP over the cost of a gigabyte. In the spinning disk days, we've been primarily focused on the economics of storage in terms of dollars per gigabyte, and it's served its place well for quite some time. But now that speed of access to information is becoming increasingly critical, that dollar per IOP value is starting to kind of take over the conversation and become the more important economic metric in evaluating a storage solution.
Sounds like it's hard to underestimate the impact that flash is having on the storage industry.
That's absolutely true. And so let's go into the bit of the kind of the technical underpinnings of why flash is so much different than spinning disk. So speed of access is really about what flash brings to the table. So in a computer system application environment, we have to process information with CPUs. We have layers of area to store information. Now, main memory in a system can be accessed extremely fast by the CPU. As soon as we get outside of the server, however, spinning disk has a time to access that is many orders of magnitude, as much as 6 orders of magnitude, or a million times slower than accessing information that's inside the server in memory. If we're able to use flash storage, we're able to chop a couple of orders of magnitude off of that and significantly reduce the time to access of information by the CPUs that are able to process. The bottom line is that the application is able to get the information it needs, process it, and deliver meaningful results to end users and to leadership whenever necessary.
So Jason, I think as you pointed out, using flash is different than using spinning disk. You want to go into some of the technologies and how it's used?
Absolutely. So like most technologies, there's a lot that's good about flash, but there's also some things that we have to be careful of. I mean, flash is just memory chips, right? So what's important is that what's different about it. So there's a variety of different types of memory chips available. Some that are used very close to where information is processed, and some used a little bit further away. So the types of memory chips that we normally work with, they're not persistent. So if we lose power, all the information that's contained in those memory chips goes away. Flash memory is different. Flash memory is persistent memory chips that doesn't require power to retain information. Power is only used if we need to read and write information. And it works a little bit differently. So instead of using voltage, we use charge. And that's important when we get to talk about how we have to work with these memory chips and why we treat them differently as a storage tier than we would memory when we're normally working inside of a server.
Do you want to talk about how it's erased and written, et cetera, the specifics?
I think maybe just maybe less than a minute on this, so we don't get too far into the weeds, but really the bottom line is that we have to work with flash differently than we work with traditional spinning disk. We're able to write information the first time at a very granular level, but doing erasure and then rewriting information functions very differently. We have to do an erase at a very large level of information before we can do an overwrite. So flash is fast, but it's different on day 1 than it is on day 365 and day 730. When we're working on our laptops or working on our cell phones, we're maybe not as concerned about how flash performs on a long-term basis, but in a data center environment where we're paying a significant premium for performance, how flash is dealt with, how it's worked with by a storage array is very important to ensure that you're getting really the bang for your buck, not just on day 1, but also on into the point where you're at year 2 and year 3 of the technology.
So we keep hearing about flash can wear out. How concerned are we in today's kind of products that we'll talk about that wearing out of the flash is something to be concerned about?
Well, it's certainly true that individual parts of flash cell are going to wear out. So the important thing when we're evaluating technologies is how do the products handle wear leveling? Because it has an impact not just on the life of the products. Certainly, we've working with vendors that have good warranties, good support. So if the drive fails, we're going to be able to get it replaced. But it also has a significant impact on performance on an ongoing basis. And so when looking at an all-flash strategy from a particular vendor, it's important to understand how they handle things like wear leveling and keeping the devices from wearing out, in addition to how they work that into their performance strategy.
So flash has been around a while. What's slowed it down until now, and why is it really coming to market in such a abrupt way now, recently?
So one of the primary barriers has long been cost. So flash storage that has the type of reliability that's appropriate to the enterprise has been significantly more expensive in terms of cost per gigabyte than spinning disks. And so it's a very challenge to find applications that have enough economic value that justify the price of flash. How it gets packaged from a reliability perspective is another concern. You can't simply take flash modules and throw them into a storage array that was architected for disk and expect to have consistent performance and reliability when using whether it's firmware or operating system on the storage array that just wasn't designed for flash. And then how do are we able to scale up the way that the flash storage arrays work to be able to get to the size of enterprise applications?
So a lot of the solutions we're going to talk about either did not fully adopt an all-flash strategy or have just recently added the high availability features we're seeking to bring it into these environments.
Yes. But I would say, and without question, that the biggest sort of barrier to adoption has been the cost factor. And what this slide, you kind of borrowed this from a vendor to show what has really changed the game in the last about 6 to 12 months on the the cost per gigabyte nature of flash. So if we look at just the usable flash, what we're actually purchasing and can store in terms of raw data, the cost is actually still a significant multiplier above spinning disk. But if we're able to adopt some of the efficiency technologies that have existed in the IT industry for a while, but apply them to flash, so things like compression and deduplication, we can significantly drive down the cost of flash to get to the point where we can bend that curve to be more in line with and potentially even ahead of spinning disk. With spinning disk, we can use dedupe and compression to an extent, but nowhere near as effectively as we can with flash. So this is one thing that flash has available to it that spinning disk doesn't necessarily have the ability to take advantage of. And so this cost curve reduction is really a big game changer in bringing flash to the data center enterprise environment.
So the data efficiency algorithms with deduplication and compression are very, very important to keep the price realistic. And we think that this might be, as all vendors, be a little bit aggressive on where the prices are today, but certainly you can see the impact of data reduction.
Yeah, as anything with with data reduction, whether you're doing it in primary storage or in data protection, your mileage will vary. So it's important to work with an organization that has the technical wherewithal to examine your data and understand what type of space efficiency your data is likely to get so that you can make the right type of decision around cost comparisons between a vendor that offers one type of space efficiency, but maybe not another, compared with a different vendor that might offer more.
So it definitely depends on the use case where you're going to get the benefits of that. Where are the high potential use cases for using flash kind of today?
So if you look at where these space efficiencies can offer the greatest sort of economic impact and make flash more affordable, with deduplication, we're primarily talking about virtualization there. And that could be either virtual server environments, particularly high-density virtual server environments, where we're getting to the hundreds and potentially thousands of virtual servers, but also in virtual desktop environments. VDI is a particularly intense workload to run on traditional storage arrays, where flash handles it quite well. And if you look at the type of deduplication ratio you can get in a virtual desktop environment, it's easy to understand where that space efficiency can really change the economics of flash.
So primarily, products that can dedupe will get a significant benefit that can apply to cost in virtualized environments, and products that can do compression will have that opportunity to have that benefit in primarily database environments. Is that fair?
Yeah, it's definitely important to consider how a database works differently from virtualization, and that compression is where we were able to get the type of space efficiency that allows a flash product to be change the economics in a database environment.
So you can package flash in almost any way imaginable. Let's talk a little bit about some of the trends we've seen recently with some of the different ways of delivering flash to the application.
Absolutely. So before I transition to that, I just wanted to offer a note to participants that we do have a Q&A window that's available that allows you to enter questions that towards the end of the presentation we'll try and answer as many questions as we can. So please use the Q&A feature of the presentation manager that we're using if you have a question you'd like us to get to.
Do you want to talk about what people have been doing with server-side flash and packaging and PCI cards?
Certainly. So there's a couple of different areas where flash has been used to accelerate applications over the past couple of years. One area that was had a lot of kind of traction and press and was really exciting within the last couple of years is server-side flash. So in this case, we're talking about taking flash and putting it onto a PCI card usually, and putting it in a server to allow some extremely fast access to data for applications inside of a server. So the use cases for this have been where extreme latency reduction is what we're trying to work for, but particularly for read-heavy workloads. So one of the challenges in server-side flash is that it's essentially a read-only accelerator. Because we've got a single point of failure on a given flash card, doing write caching is a little bit challenging. Now, for applications that have been tuned a bit to this, where we can put maybe some temp data, then we can get some write acceleration as well. But primarily, we've used this for read acceleration. Now, the momentum behind this area of the flash market has slowed quite a bit, in part because of the challenges tuning workloads in order to use server-side flash. We don't see this technology as necessarily going away, but it takes a lot more effort for an organization to adopt this. It's high cost to acquire in terms of dollar per gig. Makes it limits it to some fairly niche areas within an environment, and the amount of effort required to really tune an application and take advantage of it means that it just doesn't have the type of rapid growth that we're going to see with other use cases of flash and storage.
There's also no shortage of startup companies and existing companies that have come out with hybrid flash solutions. It seems like everybody who's got a storage product now has flash. You want to talk about the difference between a hybrid flash and maybe the all-flash that we're going to focus on?
Absolutely. So where we see hybrid flash arrays being is essentially table stakes within the storage industry, that no longer are we going to find it very common that you would have an all-spinning disk array product, except for in some kind of niche areas around deep archive and object storage for extremely low intensity workloads where cost is the primary factor. For the bulk of enterprise storage, in terms of size of data that exists in an environment, hybrid flash arrays are the best use case. So in this case, we're taking a combination of traditional spinning disk and adding flash as an acceleration capability. Essentially, every vendor that competes in the storage market has a hybrid flash offering. So some of them are from incumbent traditional vendors like NetApp, EMC, IBM, HP, and Hitachi, where they're taking their existing disk products, they're adding flash to be able to offer a increase in IOPS and a significant reduction in latency from adding a little bit of flash to the mix. There are also startups that have come into play since flash has been on the scene, where they've been able to create their product from the ground up to leverage flash as part of its architecture. So where we see hybrid flash arrays really shining is when we have a specific working set that we want to accelerate. Now, a lot of applications in an enterprise environment sort of meet this criteria. I may have a 10 terabyte database, but really only about half a terabyte of that is really being worked on at any given point in time. And as long as we have applications where that's understood, a hybrid flash array can offer kind of the best of both worlds, where I get the cost per gigabyte of a traditional disk array with some of the IOPS and latency characteristics of flash. And so we see that the hybrid flash market as still being the largest area of enterprise storage for the foreseeable future.
Yeah, I mean, between all the emerging companies and the existing companies kind of saying, we're going to stomp out the emerging companies if you would, this is definitely a significantly larger market near term. Let's focus a little bit on the all-flash arrays, because that is a specific type of architecture that leverages all-flash, no spinning disk.
Yeah, so this is an area where we need guaranteed latency, because when we look at what a hybrid flash array offers, it's got some flash, but it's still primarily spinning disk. And as long as we're staying within our sort of working set area, we're going to get flash-like latency. But as soon as we have a miss, we're going to fall back to the latency of traditional spinning disk. So I had that slide area where, showing the difference between access time on, memory versus storage, and we had that huge gulf between. If we get to the point where we're outside of a hybrid array's working flash, we're going to fall all the way back down to that sort of worst-case scenario of spinning disk. In a lot of applications, that's okay. But for some applications, that's simply not acceptable. And for those use cases, that's where we would start to look at all-flash arrays. These offer the guaranteed latency of flash end-to-end, and that's some cases where we simply don't want to take the risk of falling down. So traditional Tier 1 applications, where it's simply the economic value of the app is so high, it's worth it to guarantee the latency of those apps. Other use cases where if we don't understand the working set, or in my previous example where I had my 10 terabyte database, if the working set isn't a half a terabyte, but is maybe maybe the whole 10 terabytes is the working set, those are areas where we simply can't optimize enough with a hybrid array to get the type of performance we're looking for. And that's where all flash comes in. And then VDI. I mentioned earlier that VDI offers a really intense workload to a traditional storage array. It's very, very random. The working set is kind of all over the map, and it can be particularly intense on writes. And that's where all flash can be, in some cases, the only solution to an effective VDI deployment.
So Data Link's fortunate enough to have an opportunity to partner with almost every major storage partner in the market, but we do have to be somewhat selective. Let's talk a little bit about some of the considerations we make when we look at a flash strategy and a flash partner.
Sure. So what we're looking at in terms of an all-flash strategy, for it to be really effective and something that we want to bring to our customers, start with the ability to execute. So data is stateful. Data is extremely important. So uptime is one thing, but losing data is a whole another ballgame when it comes to kind of the seriousness with which an organization looks at a product. Not all of the startup vendors are going to get this part right. They may be able to get out into the marketplace and have some early success, but none of these products are perfect. And the question is, where are their flaws, and will any of them expose something where we could potentially have data loss, and that could be a huge threat to whether the startup can even continue to exist. We also look at the completeness of the solution. Do they have the type of storage management capabilities that enterprise environments have come to rely on, like snapshotting, mirroring, and of course the high availability. We also then have to look at the kind of the design architecture and what a particular product brings to the table. So if we're looking at a purpose-built flash appliance that has the ability to guarantee latency under both reads and writes that we're trying to bring to a database environment, we look at that very differently from a product that's more of a me too offering, trying to throw some flash behind an architecture that really was designed for disk. We're also looking at how a particular architecture deals with some of the issues we mentioned earlier around wear leveling and garbage collection, so that we can deliver consistent writes not just on day one, but 2 years into the future. We also have to look at the efficiency capabilities of the products and how that is able to make a product price competitive, not just in dollars per IOP, but also in dollars per gig. So I mentioned that dollar per gig can sometimes be the kind of the deciding factor, but in most cases, dollar per gig still matters. And so if we can bend the dollar per gig close enough to where dollar per IOP becomes a more important factor, that's something that becomes very critical to whether a flash strategy is going to be effective or not.
So the drastic change in technology, the velocity at which it's happening, it really creates an opportunity for disruptors to emerge in this market, while the so-called oligopolies, address that as fast as they can, how fast this technology is changing things.
Yeah, absolutely. This is an area where sometimes we'll see slides that say flash changes everything. We still have to store information, but the way in which we do it with flash is so different and offers such a completely different type of performance and capability that in many cases we have to completely rethink how we work with storage. And that's where the opportunity for some of the upstarts to change the way customers think about managing their data and think about how they store their data can turn some heads and get people looking at some of these startups and away from some of the incumbents.
So lots of startups out there. Probably some of them won't survive. What we've done is taken an opportunity to kind of look at what we see as some of the strategic solutions. So let's shift gears and talk about them. Let's talk about them in alphabetical order, just to be fair.
Indeed. Sometimes it can be challenging to determine, how do we kind of rank these? Because they all have different strengths and weaknesses, and I think alphabetical is probably the most fair that we can bring. So let's start with Cisco. Sort of late last year, Cisco made an acquisition of one of the startups named Whiptail, and Cisco has now renamed this product Invicta. They folded the Invicta product line into their the UCS compute platform, so the full name would be Cisco UCS Invicta, and they've really tried to very closely couple the Invicta platform with the rest of the UCS architecture. So some of the value proposition that exists in terms of shipping product comes over from Whiptail, and then with some of the work that Cisco has already done and is bringing further to the table, the value proposition is going to sort of kind of continue to evolve. So some of the strengths that the technology itself brings to the table, a very balanced read-write capability. So when looking at the architecture of Invicta, the operating system was designed to from the ground up to work with flash, to be able to sustain IOPS, not just in terms of reads, because read IOPS is something that flash inherently does really well, but also be able to bring that to the right side from a performance perspective, and that's something that they've really spent a lot of time optimizing. So currently the product is integrated with UCS through their UCS Director platform, but eventually this is going to be integrated into the UCS Manager portion, to where you'd be able to have storage provision from the same pane of glass that's provisioning your blades, provisioning profiles to the blades, and doing all of your compute management and the network that ties all of it together. We see this as being eventually this will be the biggest differentiator that the UCS Invicta platform brings to the table, is the full end-to-end integration of a compute network and flash storage into a single unified experience for an end user. This is something that can be extremely different from the traditional way of building things, where we've got a storage product from one vendor, a network product from another, and yet another vendor's compute, using sometimes either different management tools or bolted on tools to try and manage it all together. Once the UCS Manager integration is complete, Invicta will offer a pretty compelling end-to-end solution for high-performance workloads, whether it be a high-performance database or highly virtualized environments. So the last area in terms of technical strength, The way that they're able to scale with their architecture allows them to get to capacity points that most other solutions simply can't reach. And we're looking out at the roadmap that Cisco has provided, that this is going to continue to increase at a rate where their high capacities are going to be fairly unique in the marketplace.
So we can all remember a time 5 years ago or so that Cisco was not a server company. Now it looks like they're going to become a storage company. That could be potentially very disruptive.
Absolutely. If you look at the financial strength that Cisco has, their reputation in the market, and their ability to execute on their UCS strategy, there's every reason to believe that, including Invicta as part of the UCS platform, is going to be a very successful play for Cisco going forward as they enter the storage market.
So let's hear a little bit about EMC, the standing market leader in storage. I'm sure they're very focused in this area as well.
Certainly. EMC has had a long-standing strategy of working on both in-house technology and evaluating acquisitions in order to complement their portfolio. They've prided themselves on being a portfolio storage company that relies on acquiring or developing best-of-breed technologies and then combining them as part of an overall storage environment. And XtremIO matches right with that strategy. So when EMC looked at the flash marketplace, they were an early leader in bringing flash to the enterprise. They were able to add flash drives to their DMX platform quite a number of years ago. At that time, the cost was so high that there was very few customers that could use it. But they've been kind of leading the charge on having flash as part of their solutions. But when it came time to do an all-flash product, the one that was not a hybrid, they realized pretty early on that you couldn't just retrofit and see the same type of benefits that they would get with a purpose-built product. And so they went and considered a variety of different options on how to meet that challenge. And what they found was a startup called XtremIO that matched the technical priorities of EMC. So that's rely on Intel, rely on scale out, and have sort of an uncompromising best-of-breed performance profile. And so EMC acquired XtremIO back in May of 2012, before they even had a product on the market. So EMC took some time before releasing the product in general availability, completing the solution and polishing it up, and then released it in November of last year. So when looking at the XtremIO architecture, it's really a no-compromises flash-based special platform. So the way that it is designed is around the concept of an X-brick. So rather than a more traditional model of controllers plus shelves of disk that you can then add capacity sort of as you go, the XtremIO architecture combines the compute and the storage into a scaling model called the X-brick. So each X-brick has redundant controllers with processing and memory and flash capacity to go with it, so that as you're adding your capacity, you're also getting more processing power to continue to scale performance. So in the end, with the current shipping product, they're able to get up to 80 terabytes of usable physical capacity and over 1 million IOPS, which is a very high level of performance that completely changes how we think about storage array performance in the enterprise.
And in our testing, we found it to be an extremely high-performance solution.
We did, but what was most impressive about it was its ability to retain its consistent latency as it was delivering that performance. And this is something that EMC has been very clear on in their how they talk about XtremIO and where it is that it's not enough to be fast when the system is partially loaded and used up to a certain percentage. It should really be able to perform and deliver flash latency even as it's being significantly stressed. And that was one of the things that impressed us about XtremIO, is that sort of no compromise performance design. Other strengths of the solution, it's got the large ecosystem of EMC products to go around it. Obviously, EMC's got a huge market presence, and the support organization has sort of earned its reputation over the years. In terms of how it also works well from a space efficiency perspective, their deduplication is an always-on feature that allows it to really compete from a price perspective on effective capacity and take that, maybe up to 80 terabytes of usable physical capacity and maybe turn that into as much as 400 terabytes of effective capacity in a virtual server or virtual desktop environment.
So EMC's kind of been in front of the flash market. They were one of the first companies to say how impactful this is. But that has primarily been about adding flash to their existing products. I got to imagine that Extreme I/O is a major investment, but also it's going to take potentially some opportunities away from maybe their other storage lines.
Now, this is certainly an area that EMC has been increasingly sort of public about, whether it was in the run-up to EMC World a couple weeks ago or at EMC World itself, acknowledging that the Extreme I/O platform has the potential to displace even their own existing products, such as VMAX and VNX, but that they need to really become comfortable with themselves internally that when that's the right thing to do, then they're going to have to do it, even if it means eating into their own ecosystem.
So Datalink's had a long-standing partnership with Hitachi Data Systems, where we've seen that be one of the most high-performing and most reliable products in the market. Let's talk a little bit about how they're addressing the flash market.
So when you look at the approaches from a variety of these different vendors, it isn't too surprising that their strategies play to their strengths and to their long-standing sort of approach to the storage market. So with Cisco, it's integration and how everything ties together in that platform. With EMC, it's having the complete portfolio of best-of-breed solutions. Hitachi's strength and strategy has been about differentiated hardware that offers the level of consistent performance and extreme reliability that other solutions aren't able to offer. Their flash strategy is really no different. And so what they have done is they've relied on their existing platforms, the HUSVM and VSP in particular, as part of their sort of all-flash strategy. So at this point, they don't have a product that is purpose-built for flash on the controller and sort of software side. Rather, they've done their innovation in how the flash itself is packaged. So they take, rather than an SSDs from an existing supplier like a Toshiba or Samsung or Intel, Hitachi takes and goes and buys flash chips and packages them themselves. They put a lot of processing power and a lot of sort of microcode level optimization into their low-level flash drives and then tie those to their existing controllers and software. The end result is the type of strengths that we're used to expecting from Hitachi. So extraordinary performance in terms of IOPS, the ability to deliver that very consistently and do it at a very high density. The ability to provide all of that capability with a level of uptime that is unmatched, including the ability to extend their 100% uptime guarantee to an all-flash storage product that other companies simply aren't willing to take it quite to that level. And all the while being able to leverage their other features like externally virtualizing storage, replicating to their other platforms where you may want to replicate from an all-flash to a traditional spinning disk or hybrid array from Hitachi. So it's really they're taking all of their normal strengths and just applying all-flash to it. So the one thing to bear in mind is because of how they're leveraging that, they aren't able to take advantage of some of the efficiency benefits, such as deduplication and compression. So sort of you get the good of what's always there with Hitachi, and you also miss out on some of the differentiated software features, as that's not traditionally been a Hitachi strength, at least to this point.
Great. So, we've been NetApp's top partner for some time. Their flash strategy, they appear to have multiple investments in the flash strategy. Do you want to go kind of into what they are and why?
Sure. So I think that one of the interesting things about how NetApp has moved to approach the storage market and apply it towards the flash part of the storage market over the past couple of years is their sort of realization and almost embracing the fact that you really are going to need to be more of a portfolio company. So as much as they have trumpeted the ONTAP unified storage array and storage platform as being a key part of their value proposition, they've recognized that maybe one size does not fit all. One size may fit most, but it does not necessarily fit all. So with NetApp's strategy, they currently have kind of a three-pronged approach. So if you look at what they're offering in the area of the database market in particular, they're using their E-Series line of storage controllers that they got as part of their Ingenio acquisition, and they're releasing an all-flash version of that called the EF. So they have the EF550, which is a product that combines the E-Series with flash and offers essentially the reputation of the E-Series for being very fast and being very reliable and being the most widely shipped storage platform from an OEM perspective. There are literally hundreds of thousands of the E-Series arrays out in the field. So they're used widely in data analysis and in high-performance computing, and it's something that is a strength of the EF550. When approaching the virtual server environment, NetApp offers a different platform to take advantage of the strengths of their solution. In this case, they're spending more time talking about the all-flash FAS. So in this case, they're taking their core strength, data ONTAP, applying the rich feature set and capabilities that brings to the table in an all-flash form factor, relying on their FAS 8000 series. So the FAS 8000, which first came out in February of this year, offers quite a bit more performance from their previous generation storage controllers. When combined with native SSDs and flash storage, they're able to offer an experience that's somewhat similar to the other all-flash arrays, but with all of the data management capabilities that ONTAP brings to the table. So, for example, NetApp has offered snapshots, replication, cloning, deduplication, and compression in the spinning disk market for a number of years. Combine that with flash, and you've got a known platform, an ability to integrate with an existing enterprise environment, but with the type of all-flash performance that you'd expect from SSD.
So with ONTAP, widely touted as the world's #1 storage OS, you can add flash, get all of the things that grew it to that space, but they certainly saw the need to build kind of, I guess, the more focused and maybe higher performance solution, EF, for primarily databases.
Right. And then if you look at where they recognize that these products are sort of not all that. They don't have everything kind of that a given customer would want in a single box. They've offered sort of the third prong of their assault. So EF is outstanding for databases, but with its lack of space efficiency makes it not so strong in virtualized environments. All-flash FAS, very strong in the virtualization areas, not as strong in database, and doesn't quite get to the level of performance and scaling with flash that some of the other dedicated products are. So the third prong in NetApp's case is their FlashArray product. So that's something that they've been very public about as being sort of their next generation flash strategy, but it's not available today. And so there isn't something that we can even really throw a slide up that says, here's what its strengths and weaknesses are, because right now they're all just on paper.
So that kind of leaves us with one of the emerging partners, and it's almost hard to start up, I call them a startup anymore. Pure Storage has got about a $3 billion valuation. Let's talk a little bit about what we like about the Pure Storage solution.
Absolutely. So with Pure Storage, what we have is a startup that's been around for a couple of years, has been shipping products for a little bit less than 24 months. And in that time has really kind of taken the storage market by storm, in part due to their approach. So with some of the other products, the focus is on trying to get the absolute last ounce of performance at the absolute last lowest latency that we can, and really focused on the performance area of the flash market. A little bit counterintuitively, that's not necessarily Pure's approach. So Pure's approach is to sort of say flash is wonderful. We're going to take flash, but we're going to try and take it into the every part of the enterprise rather than focusing only on the absolute extreme performance use cases. So the way that the Pure Array is architected is to get flash-like IOPS, flash-like latency, but have the type of space efficiency and cost of ownership that allows it to be competitive in all areas of the data center enterprise. So Pure isn't necessarily going to be the fastest in terms of IOPS. They're not necessarily going to be the fastest in terms of low latency, and it doesn't have the type of sort of guaranteed performance that some of the other products have. What it does offer is an excellent level of performance that you'd expect from Flash, excellent high availability that you'd expect from a product positioned at the enterprise, but with an economic model that means that instead of asking the question, why Flash, you start to consider the question as why not Flash. So it's really a different way of taking Flash and bringing it to an enterprise environment. Rather than chasing the one application that needs it, it's saying, what if I could make the price such that you'd want to consider this for all of your applications and essentially just take performance completely off the table?
So I think we've seen that this is, like storage has always been, but maybe even more so now, highly competitive. If you have relationships with NetApp, EMC, HDS, there's a strategy there, but there's also some disruptive solutions. It's not only Cisco coming in and saying we're in the storage market, but some of the really valid startups like Pure.
Yeah, I think one of the sort of comforting points is that after what was kind of a rocky part of this market from an all-flash perspective 18 months ago, has really stabilized in terms of the incumbent vendors. And so if you're very comfortable with the relationships that you have and the companies that you've been working with, you can deploy an all-flash solution from any of them and feel comfortable in the knowledge that none of them have any glaring flaws or things that would make you want to completely avoid them. Certainly, as we've discussed, there's appropriateness to use case. So, for example, the EF versus the all-flash FAS from an NetApp perspective, and looking at Extreme I/O and their lack of compression maybe being a point of caution on database versus their excellent support for virtual servers. Hitachi, if you're like Hitachi for their reliability, certainly their all-flash approach brings that to the table. And so while there's the potential for a lot of disruption, you've really got two good choices to make. One is stay with where you're at and be able to deploy Flash in a way that can bring a lot of value to your environment. But also there are some game-changing players like Pure Storage that can kind of bring Flash to areas that you maybe hadn't previously considered.
So I know, Jason, we've had the opportunity to bring in all these products. You led a team to kind of do a lot of evaluation of that. So great opportunity for those on the line to tap your expertise. While they're thinking up some questions, maybe kind of just summarize what we've just covered.
So what we tried to do in bringing these products into our lab environment was to really validate claims. We weren't necessarily looking at trying to push every product to the nth degree. We wanted to prove that what they said that they were delivering to us could do, that was able to do it, and most importantly, maintain that under various failure scenarios that expect an enterprise environment. One of the things that we started with in this presentation was how Flash is different and how it performs differently and how it needs to be treated differently. And we made sure that we designed testing scenarios where our failure modes and what we were expecting out of the products reflected the differences in Flash. And we tried to stress each of these arrays to find, where did it start to have quirks? Where did it start to behave a little bit differently? Where did it stop providing that Flash experience that we're really paying for when we're looking at these products? So that's something that we have available to our customers as a part of working with Datalink, being able to have that conversation, do whether it's a side-by-side demo, whether it's just a deep conversation, all that is part of why we made the investment in bringing those products in. So then now moving to summarizing everything that we've talked about so far. So we see Flash as being very disruptive to the storage market. In some cases, that's the PCIe-based Flash, and then in the broader sense, hybrid is obviously a big part of the environment. But all Flash is an area that can completely change the way that we approach storage. So Flash is not a panacea. It's got a different cost profile. It has a different performance profile. It has to be worked with differently. The way that we can get the cost profile to match more like spinning disk is by using space efficiency techniques like compression and deduplication. If we look at their use cases, just to summarize, really the three big areas are the high performance, mission critical database applications, VDI, and high density virtualization. They're currently the sweet spots that really cry out for all flash arrays. You've got a variety of choices from the different traditional storage vendors and some of the emerging all-flash vendors, and everybody is trying to outdo each other in driving that rapid change in the industry. And really, at the end of the day, DataLink is here to help our customers evaluate the various solutions, evaluate their requirements, and then try and match the right product to those requirements.
So I think that's a good summary of the key high-value, high-impact use cases today being the highly virtualized environment, either VDI or just highly virtualized in the databases, and certainly being aware of the benefit that space efficiency can have. There's a couple of questions already online, and if people want to ask some more, I think you answered the first one about NetApp putting SSD in their FAS filers. That's their all-flash array.
Yeah, so NetApp has recently released a couple of white papers that are valuable and showing the testing that they've done internally, particularly with the 8040 and the 8060 in the VDI space. And really what they showed with those white papers was that while they can't, sort of scratch the upper limits of performance as the ground-up redesigns are, they're able to drive some very significant IOPS out of the 8000 with that all-flash, and we certainly can work with you to understand what those white papers might mean in your environment.
So there's another question, maybe a little bit highly controversial. Don't know if this is coming from a particular vendor or some interested party that just wants to understand the answer. So I've heard from a number of companies they had the entire Pure array completely go down. Can you comment on what we've seen from availability from Pure Storage?
So that's certainly possibly true, but then every storage product that's ever been released has entirely gone down. So whether it's VMAX or DMX or VNX from EMC, whether it's any of the various NetApp or even the Hitachi products, as noted for the reliability as they are, every single box that's ever been shipped has completely failed at some point in time. These are imperfect products designed by us imperfect humans, and so what we saw in our lab in terms of failure mode testing was a product that was designed with a very solid HA capability built into it. So it's designed as having an active-active front side in order to be able to provide a very clean HA experience to the host level while using an active-passive processing configuration so that there's no impact to performance during upgrades and during failovers. We tested online firmware upgrades and were able to achieve those with minimal host impact from performance and zero impact on availability. With most of these, anytime you do an upgrade, there'll be a blip from a performance perspective. The important thing is, were they able to maintain availability? And whether it was in failure modes or whether it was in terms of performance, we were able to, or in terms of upgrades, the Pure product was able to pass all of our tests pretty easily from an HA perspective.
So then another one, I think we covered at high level, but I think it bears kind of repeating the difference between kind of the approach that the hybrid storage pools are taking with tiering versus the all-flash arrays. We talked a little bit about it, but it makes sense to kind of compare those again.
Sure. So as we sort of mentioned when we were in this area, the hybrid storage arrays are we're combining flash and with spinning disk. And for the majority of application workloads out there, hybrid is an excellent choice. So if you look at what we're trying to do there is take our mix of applications that exist in an environment, and we're trying to accelerate the part of it that we're working on. In most environments, we've got a large section of data that we value it, we want to store it, we want to keep it, but we're not necessarily accessing it all the time. In a hybrid array, we're allowing the algorithms of the array, and those algorithms are very different from one vendor to another, to find the sort of low intensity of access data that sort of less hot information and get that down onto a less expensive tier, whether that's 10K SAS, which is certainly less expensive than flash on a $1 per gigabyte basis, and then down onto SATA, where we can have really the best bang for our buck. But that ability to select the data, that ability to find what needs to be sitting up in the flash tier, that's a challenge, and that's something that is hard to do dynamically. And really what differentiates what the all-flash arrays do versus the hybrids is what happens when the algorithm doesn't work or when it can't predict what part of it's going to be hot. If I miss that cache tier, if I miss the part of the hybrid array that's flash, I'm back to spinning disk latency. I'll go from sub-millisecond to tens, 20s, potentially even hundreds of milliseconds in terms of random read latency. And that, in some cases, in some applications, that's completely acceptable, and that's where hybrid offers the best value. But for some applications, that simply is not tolerable, and we need to maintain that sub-millisecond latency for everything. That's where all-flash can really be a game changer.
So there's a classic question, which I think gives an opportunity to talk about kind of the role we play for our customers, that we did do a lot of work with the partners as not just their technologies, but also the companies themselves. And the question was, who won the bake-off? And I guess it would be fair to say that it really depends on your criteria. We're certainly willing to try to figure out which one makes sense to you, but it wasn't a bake-off per se.
Exactly. Well, we weren't necessarily trying to pit vendor A against vendor B. What we're trying to do is pit vendor A against itself and its claims. Evaluate, does your product deliver on what you say it's going to? It's not that we didn't compare and contrast them with each other, but we were mostly trying to make sure that as the vendors were telling their story, that they were at least accurate or mostly accurate, and that we would have enough information to work with our customers to understand where the inaccuracies are and where they may be stretching the truth a little bit. And so what we found was that in general, what the vendors told us, really lined up with what they were saying externally, with what their product delivered. And so if you look at Extreme.io, they spend most of their time, EMC and Extreme.io, touting the heights of their performance and their ability to drive consistent latency. And they were absolutely able to do that in our benchmark testing. They were able to maintain that flash level latency through the full band of block sizes and intensity of workload that we were able to throw at it in a way that was extremely impressive. On the other hand, if you look at the way Pure positions themselves and what they talk about their product, our testing essentially bore that out. They didn't quite have the same level of performance, didn't quite have the same level of latency, but it was still flash-like performance, but delivered with an efficiency model that may make the economics a little bit different. And we saw the same thing with what Cisco was touting. Very balanced, very high performance on read versus write, moved towards a very coupled model, and currently in UCS Director and moving to UCS Manager. So what we found was that there weren't really any losers in the sense of the product just failed to live up to what it said. That's not to say that they don't have warts. All of them have quirks and warts and little things that we have to architect around. But we really didn't find any losers in terms of our comparison to the various vendors.
And there's this is really very, very, very highly competitive market. I know there's things that weren't addressed. There was a question about the IBM Texas Memory System solutions. But when you look at some of these market-leading players and who they feel like they're, quote, competing against, we have what appears to be most of the majors, at least in each other's eyes, covered.
Yeah, I would say it's definitely fair to say that Datalink focused on obviously our existing vendors, and then on some of the other vendors that we wanted to bring into the system. So we haven't traditionally been an IBM reseller. So we certainly have spent plenty of time evaluating that technology as whether it differentiates itself enough. But because we're not really an IBM partner from a broad standpoint, that's probably the biggest reason why we didn't look at the Texas Memory Systems solution. So what we tried to focus on was the players that had differentiated themselves in the storage market in general. So the incumbents, you look at NetApp and EMC and Hitachi's strength versus IBM in the storage market, and then whether their products differentiate themselves. That's part of how we tried to focus. There are some other startups that we we didn't talk to that we may in the future. So if you look at where SolidFire, their strength in the service provider area because of their quality of service and the type of integration they offer, that's starting to become a company that we may want to look at more closely. And Caminario is trying to kind of become the next, whether it's Pure or Extreme IO. We're always looking at the market and evaluating what additional players become relevant. We feel that the products that we covered in this presentation really are the ones that are the most relevant to the majority of our customers.
Yeah, and there's even some others that we have in the lab. Nimbus Data is one, some of the technology bake-off in the market and is coming on in many ways.
Yeah, we see Nimbus as a kind of an up-and-comer that we didn't have a specific slide on them, but we're definitely in the process of evaluating that technology and potentially adding it to the portfolio as the product gets a little bit further towards what we're looking for. But it's definitely promising. We're keeping an eye on it, and we see that as being something to watch going forward.
So there was another question. I think you had talked about the Pure Storage and high availability, failover, et cetera, and the question was, did we find any anomalies, or essentially how did the Extreme IO perform in high availability environments?
So what we saw with Extreme was because of their array is intentionally designed to be symmetrically active-active, the two arrays performed differently. They performed the way that we expected them to perform. So the Pure had a blip and then went back to having 100% performance because that's how it's pitched. The Extreme IO, because it's active-active, they've tried to design to having the highest performance they can under the everyday scenario when you're not in a failure mode. And so we did see a performance loss when one of the controllers was taken offline. Something in the range of 25% or so was the overall kind of reduction in performance that we saw. But that matched essentially what EMC said. Yes, we're going to take a loss in performance if one of the controllers in the X-Brick goes down. Their counter to that is, don't you want the maximum performance during the 99.999% of the time when you're not in a degraded state? So it's just a sort of a difference in approach. I would say that the big thing that we got out of it was that what they said matched our experience. I did mention that they all had a couple of awards, but none of them were ones that said we really need to disqualify this product and kind of stay away from it.
Yeah, and we kind of mentioned that we've made a lot of investment in the months leading up to this webinar with getting these market-leading products in the lab, having the access to the expertise of all of those companies. So while they're giving us a good education on what their product does, they're sometimes trying to point out the flaws of others. And as you mentioned, we're pretty happy with the solutions we're talking about today. We had 30-plus DataLink engineers spending the week, a week or so ago, kind of going through this. So it makes the point that we're pretty invested in this market, and there are resources across the country that have had this experience, and you can leverage as you start to look at Flash.
Absolutely.
So one last question. Any experience with Avere systems? That might be. So
the interesting thing about Avere is it's not a sort of a traditional storage product as we usually think of them. It's really an inline accelerator focused on the file space. So and really more so focused on the NFS space. While they do have a sys capability, they're primarily focused around NFS. So we have a relationship with Avere that's definitely a very interesting company, but they play in kind of a different area of the market. They're a little bit more focused on high performance file applications where they're placed in line and then accelerating a workload using Flash. So to that extent, you could say if you combined Avere with a traditional NAS product, in the end you have a hybrid storage type experience. But where we focused on where all Flash the vendors are traditionally focusing on high intensity database, high density virtualization, and VDI, those aren't areas that Avere tends to focus on with their product.
Well, thanks, Jason. We have a few more questions coming in. We are going to be sending this presentation out to everybody. We will also follow up with any questions we did not get an opportunity and to answer yet, and there'll be an opportunity for them to get additional questions answered. So thank you again, Jason, for your time. Thank you, everybody who listened to this webcast, and again, we'll be following up shortly.